Hope everyone's had a good show so far. I'm Madhu Rangarajan, Vice President of Products, so I run the EPYC CPU products as well as some of the Instinct products that are not rack scale, like the MI350P, like the MI430X, and some of the products you learned about today. And what I'll spend some time on right now is getting a little bit deeper into the Venice portfolio and the different flavors of it that Lisa shared earlier. And then we'll have some of our partners who actually help us make all of this happen also come and give a little bit of a view of what they're doing with us. Right? All right, so what I'm going to jump into is, all right, so I'm going to introduce the 6th generation EPYC, also known as Venice, in a little more detail. We're going to talk about how the different flavors of it span cloud, enterprise, AI, and various different subsegments. You heard a lot about Agentic AI, and we'll talk about how the Venice portfolio serves all of those different use cases. And then we'll, of course, talk about how our partners help us get where we need to get to. So you're all familiar with the past 5 generations of EPYC, hopefully, right? We started off with Naples, and during that time frame, we had a whopping, again, I don't know, 2% market share. And now we're all the way at 5th generation EPYC with Turin, and our market share went up to a good 46%. And Venice is launched today. It's, as you heard Lisa, it is in production now, and we expect that market share to go up further. And that's what this slide is showing you, is we grew rapidly from 2017 to now to this 46% market share. And the other important point here is we have 475 EPYC platforms now from the OEMs, right? And that's important for choice and for customers to be able to readily deploy our platforms. And then we also have 1,600 EPYC-powered VMs across the different cloud service providers. And that is critical as well because the world is hybrid now. So regardless of whether you are running on-prem or in the cloud or you're hybrid, we want to make sure there are choices. And that's why partnerships are important. And that's why we have partners like HPE and Dell and others helping us get where we need to. And that partnership is part of why we're able to get to this market share. All right, the 5th generation EPYC, I won't spend too much time on this because you all know it. We are already the first leading in performance. If you saw a bunch of the benchmarks that Ravi and others shared, Turin is already leading, and Venice kind of takes it up a notch, right? Turin already led in core count with 192 cores, 384 threads. We got to Gen 5 as one of the earliest platforms in the 4th and 5th gen EPYC platforms. And what we're introducing now is the 6th generation EPYC. And we like to say it's the world's best server CPUs for cloud, enterprise, and AI. And notice the plural, because there's no one size fits all here, right? There are many different needs in cloud and enterprise and for agentic AI infrastructure and AI host nodes. And there are different infrastructure limitations, and that is why we have a portfolio of Venice CPUs. I'll start kind of with the top line numbers before we jump into some details on the different flavors, right? So we have performance leadership. If you look at our gen over gen spec in trade, that's 1.8x. So significant general purpose performance lead. This is actually a pretty big jump even compared to historical gen over gen jumps. Density leadership, we went from 384 threads to 512 threads now. Memory bandwidth, a whopping 1.6 terabytes per second. That's where we made a huge leap because of MRDIMM v2, or also the JDEC version of MRDIMM. That's running at 12.8 gigabytes per second and 12,800 mega transfers, and that's what delivers that bandwidth. And PCIe Gen 6, critical to feed accelerators, delivering 64 gigabits per second per lane. And again, that's a doubling of the bandwidth. And if you look at the generations, of EPYC and how much we've gone up in throughput, it's a whopping 18x increase in general purpose performance over 6 generations, right? I think and you can see the line has gone up even steeper. So we're actually getting better and better as we go through the generations. Now, I really like this slide because there's been a lot talked about competition from NVIDIA with Vera and how it's a purpose-built agentic CPU and so on. But what I'd like to point out is that if you look at the two bookends, one is throughput leadership for scale-out workloads that care about lots of cores and as much performance as they can get in a socket. And if you look at workloads that really care about performance per core and they're latency sensitive and have critical paths that depend on how depend on the core performance, you can see that we are actually beating the competition in both. Right? We lead them on throughput by 2.2x with our 256-core CPU, and we are beating them on per-core performance by 20% with our 96-core high-frequency CPU. And another way to look at it is in the 96-core CPU, we have 10% more cores, and we have 20% more performance per core. So we believe agentic AI workloads are diverse, spanning many different requirements, and whether those need latency or throughput, we've got it both. And the Venice portfolio is delivering on that. Okay. The second thing is we compared it to some of the other ARM variants out there, as well as the existing Intel CPUs out there, right? 6980 is Intel Granite Rapids. So then there's the ARM AGI CPU, which was recently released, 136 cores. And again, we compared both our throughput and our per-core performance. And we have 2x the performance versus Intel on throughput, even more versus ARM AGI. And then if you look at the per-core performance, once again, we're leading Intel by 30% and by ARM AGI by an even higher percentage there. Now, if you look at cloud-native workloads, right, NoSQL databases, some in-memory analytics, web servers, Nginx, things like that, bread and butter of cloud. Transactional databases, again, extensively used in large cloud deployments. Again, you can see a significant leadership here across MongoDB, Redis, Nginx, and MySQL, 3.5x and 3.7x, right? It's like, in many cases, it's multi-generational leadership. And the close partnership we have with TSMC, being on leading-edge process nodes, the architecture innovations we have, all of that allows us to deliver this kind of multi-generational leadership. If you go into HPC workload, life sciences, quantum chemistry, and weather forecasting, once again, the combination of the core count we have, along with the memory bandwidth, along with the AVX512 and other vector extensions we have, deliver multi-generational leadership, again, over 3x versus what competition has to offer. And what does that mean to an enterprise deployment, right? Lots of enterprises run old servers that are pretty old, 5 years, 7 years old. And what upgrading to the new generation will allow you to do is take like 1,000 outdated servers and consolidate them down to like 82 servers, right? 77% less power, 92% fewer servers, 40% lower TCO, and it's critical now, especially with the data center space and power constraints. What that does is it frees up space, it frees up power, it frees up CapEx and OpEx dollars for other investments, more AI, more agentic AI, and so on. Now, if you look at the rack level leadership, I know Lisa spoke about this a little bit. We just compared a couple of racks. I think in the last GTC, a lot was made about Vera having 22,000 sandboxes per rack, and that being the leadership. And I think the first thing we wanted to dispel was, no, that wasn't leadership because we already had 36,000 sandboxes per rack with Turin. And with Venice, we're going to have 49,000 sandboxes per rack. right? So now, if that is a metric customers care about, we have 2.2x more sandboxes per rack. So that's an area where we already had leadership, and we're going to kind of extend that further this time. Now, let's talk a little bit about the different Venice product families, right? I think one of the themes you've been hearing throughout from Lisa and others is there is no one size fits all. The data center is getting more complex, workloads are getting more complex, infrastructure constraints are starting to become more and more fragmented, and what that drives is multiple flavors of CPU. We have the SP7 CPUs that go up to 256 cores, deliver leadership core count, leadership performance, the highest memory bandwidth with 16 channels of DDR and MRDIMM. And that's what we expect to get deployed in large hyperscale data centers that have high rack power and things like that. Then we have the Venice SP8, a little more optimized for mainstream enterprise deployments, lots of legacy data centers that are subject to rack power limits and so on, and it's a more cost-effective platform. So it has 8 channels up to 128 cores. It's a little lower power, and it's much more optimized for those types of enterprise and edge deployments, as well as storage use cases. Then we have Venice X. I think we have been doing these flavors of CPU with 3D stacking on the cache. So Venice X is going to be a high-frequency CPU that drops into the SP7 platform with 3D cache, about 3 times more cache than the regular CPUs. So think about 12 megabytes of cache per core, as well as frequencies at about 5 gigahertz. And that gives you significantly higher performance on HPC workloads. And that benefits you a couple of ways. One is just getting more performance and performance per TCO. The second is software licensing costs, because if you're able to do more with the cores you have, you spend less on software licensing, or the money you spend on software licensing goes a longer way. And the last one is something we have recently been talking about called Verano, which is going to come out next year, which is going to be optimized to connect up to GPUs, provide extra bandwidth between the CPU and GPU, and it'll have an LPDDR subsystem that lowers the system power a little more. And one thing I want to assure folks is when we named it, we didn't think about Verano. We just named it Verano because it was an Italian city and was later pointed out that, oh, that's Verano. But I think, right. Jumping a little more into SP7, I already mentioned some of this, but 256 cores, 1.6 terabytes per second of memory bandwidth with 12.8 gigahertz MRDIMMs, next generation I/O with PCIe Gen 6, and 96 cores at 5 gigahertz on our high frequency SKUs. And the reason that SKU is important is because that's what goes into our accelerator nodes. And the goal of that SKU is to make sure the accelerator, the GPU, if you're spending $50,000 on a GPU, it should never be sitting idle waiting for the CPU. So we're making sure the CPU is keeping the GPU fed and increasing the overall throughput and tokens per second you can get from the GPU. SP8, I mentioned this, more optimized for enterprise and a broad range of deployments spanning the data center to the edge. 8 to 128 cores, so you're going to have a SKU stack that's diverse and covers a lot of different workloads and use cases. It's going to have 8 channels. It's going to support 2 DIMMs per channel on memory for use cases where you want more capacity and less compute. We are going to have more PCIe lanes. So if you notice, SP7 has 96 lanes. It's a little more compute optimized. This one has 128 lanes and very ideal for storage platforms. You can put a lot of NVMEs in this. And you're going to have deployment flexibility, right? 1P, 2P, we're going to have high frequency, non-high frequency. You saw the range of core counts. And we're going to have NEBS-friendly SKUs that can be deployed for comms and telco use cases. This is the Venice X we were talking about. This, again, goes up to 96 cores. This goes on the SP7 platform, the same SP7 platform that the 256 core goes into, so it's a drop-in compatible part there. 16 channels with 12,800 mega transfers per second. And the L3 cache with 96 cores goes up to 1152 megabytes. That's 12, or whopping 12 megabytes of cache per core. And that's where the performance on EDA workloads comes from. And you can look at the frequency. This is greater than 5 gigahertz max frequency. And then we spoke about the LPDDR. So this one goes up to 72 cores, 72 high-frequency cores. It's going to have an LPDDR 5X memory subsystem that's optimized for lower system power while still delivering the bandwidth. We are increasing the interconnect bandwidth from the CPU to GPU to 112 gigabits per second. So in Venice, connecting to the current Helios, we are at 64 gigabits per second. When Verano comes out next year, the next generation MI5XX series GPU that connects to Verano will have 112 gigabits per second per lane, so significantly more bandwidth. And this will also support 5 gigahertz to make sure the GPU is always kept well fed. And we also extend all of the platform I/O and memory capabilities, right? 2P, 160 lanes, greater than 1.2 terabytes per second of aggregate bandwidth from the PCI Express lanes, as well as all of the fabric, all of the enhancements we've done to the fabrics and the CPU. Significantly more memory bandwidth and capacity. We can support up to 8 terabytes per socket of capacity, right? And what does that help you with? Keep accelerators more utilized with the bandwidth. More NVMe throughput as well as fan-out. Enable PCIe Gen 6 networking, so you can get significantly higher network throughput. And memory-hungry workloads can be served really well. You can also scale memory at CXL expansion. So what we're building is a platform that's really flexible to support a broad set of data center needs. Now, beyond all the speeds and feeds and PCIe Gen 6 and all of the other stuff I spoke about, we also have some platform management features that are critical for data center deployments, right? And I'll talk about 3 of them specifically. The first one is unified power provisioning. So when you have a platform with CPUs that consume 400, 500, 600 watts, and memory that consumes 100 to 200 watts, depending on what kind of memory you're talking about, what we saw was there was a lot of value in having the power provisioning to be done for the CPU and memory as a single entity, so you can dynamically allocate power between the CPU and the memory depending on if the workload is memory intensive or CPU intensive. And what that does is it allows you to put more servers in the rack while saving power per server, and in some cases, you actually see better performance because you can dynamically allocate more power to the memory when the workload is more memory intensive, and you allocate more power to the CPU when the workload is more CPU intensive, and that allows you to overall get more performance from the server. The second one is utilization-based power scaling, right? When you have 128 or 256 cores, let's say you have let's say someone's using just a small handful of cores in the server. In those cases, what we would do in the normal case is turbo up to the max frequency, and those cores would get extremely high performance. And as more cores come online, the frequency would drop, and then you'd get more moderate performance. Now, in some cases, customers want predictable performance across the load line, whether you're at low utilization or high utilization. And what utilization-based power scaling allows you to do is cap the power when the utilization is low and unconstrain it when it's high. So for any user that's running on a core there or a VM in that server, they see similar performance regardless of how many VMs are running in the server. And again, it's a choice, right? If someone wants to take advantage of the performance upside when the utilization is low, you don't have to turn on the feature. If someone wants more predictable performance, they can turn on the feature and take advantage of that predictability. And fast is another feature where we're seeing customers have some workloads that want high performance, high single-threaded performance, and are very latency sensitive. And then there may be a lot of workloads running on the same server that are not as sensitive to performance and latency. So what you can do here is prioritize the cores where you may be pinning processes that need that performance per core and give it priority on high frequency, while the rest of the cores get lower priority. So I think these are some of the features that go beyond the speeds and feeds and help you kind of provision the platform as a whole based on your use case. Okay. The other thing is security, and security is actually getting even more critical now because of agentic workloads. You have all of these agents running, creating code, creating new IP, creating new designs, and you want to make sure that different agents from different users are isolated from each other. So all of the different security capabilities we have, such as attestation for of the manufacturing lifecycle, root of trust that's anchored to hardware, confidential computing to encrypt the workload in memory, so anyone that gets access to the memory doesn't get access to it in plain text. It's encrypted, and without the keys, they cannot steal the data. And certification of these capabilities for regulated industries. So Venice will have FIPS 140-3 certification. And all of those together help Venice be one of the best CPUs to deploy agents in a secure manner in both regulated as well as non-regulated environments. Now, on the agentic AI, right, that's been kind of the rage for the last few months. I'm sure many of you are using agents already. I know I am. And the first thing we wanted to dispel is there's no such thing as a single agentic CPU that does it all, right? Agentic AI is an end-to-end workflow with agents doing a lot of the things humans used to do before, lots of a diverse set of workloads. They make use of GPU nodes to do inference. They make use of sandbox servers to run ephemeral code and tools. They make use of general purpose CPUs and run databases and EDA tools and so on. And which is why we see 3 tiers of agentic AI infrastructure. And some of those tiers already exist. And then we add this new tier called sandboxes. We have the host node, where we already spoke about this earlier. You want high frequency and leadership I/O to make sure that GPUs are well fed. The sandbox servers is the new thing we're seeing, which is when you kick off an agentic task on Claude or ChatGPT or any other AI of your choice, you can see it creating lots of code and creating lots of tool calls and lots of little snippets of code. All of that code needs to run in some sandbox somewhere that's isolated. And it also demands extreme concurrency because there are thousands of users trying to run all of these tools all at the same time. And so we have an optimized CPU for those sandboxes that delivers high core count at the lowest power possible to maximize agentic concurrency. And then, of course, general purpose CPUs continue to grow as part of the agentic data center because as agents do web searches, agents access databases. So as I mentioned earlier, the demand for all of those CPUs also continues to grow. And for those agentic servers, right, the one in the middle, the sandbox servers, we are delivering over 2x agents per watt. And that's actually a critical metric because you've no doubt heard of power shortages and data centers finding it hard to provision power. So the primary metric we're hearing our customers optimize for right now is how to maximize compute capacity in a given power constraint. If you look at host nodes, it's all about tokens per second because you want to maximize the tokens per second to then feed the agents and make them do work. And you can use Epic servers with the high frequency and the PCIe Gen 6 capabilities, and you see gen over gen, we've gone 1.8x on performance on a workload where the model tends to spill over into the host because especially as swarms of agents run on a GPU node, your KV cache tends to blow up. And then you have to split all of your data between the GPU and the host memory. And in cases like that, having the high bandwidth from the CPU to the GPU is critical and delivers up to 80% more performance by doing that. And general purpose servers, we've talked about that all day. You saw Lisa's keynote today. 2.3x more performance per watt. So again, back to the capacity per data center. You want to maximize your token generation, and you want to maximize your performance per watt on the sandboxes and general purpose server, and that's what Venice is delivering. Now, more comparisons versus ARM-based CPUs, right? We compared how many sandboxes per watt and how much performance per watt we get versus ARM AGI versus NVIDIA Vera, and then we showed you 5th and 6th generation EPYC. And as you can see, 5th generation EPYC already has a leadership position on both of these metrics, and the 6th generation EPYC, Venice, takes it up even further, up to 1.7 times more than Intel, up to 2.8x more agents per watt compared to some of the ARM options, and 3.x versus Vera in the case of general purpose workloads. Now, this kind of rounds out the portfolio I was talking about throughout, right? We spoke about the host node, high frequency Venice this year, Verano next year, and we focus on both the frequency and the CPU, GPU bandwidth there. We spoke about the sandboxes, which was all about high core count, low power to maximize threads per megawatt. And then we spoke about the general purpose servers, where we have SP7 for high performance, highest density, for larger scale environments that can take high rack power, SP8 that balances power, performance, and performance per system dollar for more mainstream enterprise deployments and lower rack power. And then we spoke about Venice X for HPC. So that kind of rounds out the whole portfolio. And we believe that for a true agentic data center that runs all kinds of tasks effectively, you need a mix and match of this portfolio. There won't be one type of server or one SKU that fits the bill for everything. And with that, I would like to invite David on stage, because we cannot do any of this without our partners. And David will talk about some of the stuff Dell has been doing in partnership with us. Right?
Thanks, buddy. Appreciate it. Yeah. I can't unsee that Verano remark now. Now that you've put it in my head. So good afternoon. Appreciate you having me here. I lead product management for our PowerEdge portfolio. I want to talk you through the things we're doing with AMD, specifically around Venice. Now, of course, before we go to the next slide, where have we been? I always love the tour of Italy when Madhu and his peers go through all the different code names, going all the way back to Naples, and all of the partnership we've had with them, bringing these products to market in industry-leading servers. So if we go to the next slide, what you heard us talking about earlier this year at DTW, I guess I can advance that myself. There we go. So what we really focused on with our latest generation of PowerEdge servers is building a set of platforms that could meet customers of all shapes and sizes. I can't tell you that 2-3 years ago when we started this journey, it was 100% about agents, just like you weren't thinking about agents. But we did know that we needed to provide various form factors for our customers based on the type of power they could deliver to their rack, based on the kind of cooling capabilities they had in their data center. There was an overwhelming feedback from our customers that they had limits, and maybe many of you have very real limits in your data center today. You're trying to maximize the power that you have. So we have the type of density that Madhu talked about earlier on the left-hand side. You see it there with our M9825. We actually have that in our booth here today. At a standard rack configuration of 44 OU, so standard rack height, with an in-rack CDU that you see there in the picture, you can do 36,000 cores in that rack. Now, if you have an in-row CDU, if you have a 50 OU rack, you can actually do more like 47,000 cores. So you have a lot of options there based on how you want to outfit the rack. You have our liquid-cooled IR7000 rack design. This actually includes built-in leak detection, not just inside the servers, but throughout the rack as well. So we call that our integrated rack controller. We don't have that demo here, unfortunately, but you can see it online, and you can see a video of how that works within the booth as well. So this is proving really popular for just compute density and the kind of compute density that needs to go alongside these different frameworks that our customers are deploying. So you see the context there at the bottom that makes this matter, right? We have a memory and bandwidth and capacity design point that we want to focus on, making sure that we have enough room to hold the models, making sure that we have the capability to perform all of the various operations on vector indices, contain that context in memory for as long as possible. That is very important to us as we design these systems. And then we want to make sure we have no limits on our on our I/O capabilities as it relates to the accelerators that we can support. On that note, you see that middle column there is the air-cooled servers that we're introducing based on Venice, the 9825, the 9815, and the 8815. So those are 3 different sizes. The 8815 is a 1U, 1 socket. The 9815 is a 2U, 1 socket. And then the 9825 is a 3U, 2 socket. Why do you do 3U? We do 3U because we want to be able to support 4 MI350P accelerators as well as 256 cores on each socket. So you have it all in an air-cooled package. So you have a tremendous opportunity within your environment. Air-cooled, standard kilowatt per rack, nothing crazy about power to the rack. You can deliver quite a bit of compute capability as well as accelerator capability with these designs. And then finally, as we get later in the year and we have SP8 introduced, you see what we consider to be balanced enterprise compute with the 7825, the 7815. We have a storage dense option with the 7815 XD and the 6815. We have in the booth, just another booth plug, I know it's late in the day, but we have 2 of those systems on display, the 9825 and the 9815, so definitely stop by and check those out. So what does that all mean? It means that really we have the right type of infrastructure no matter where you are in your data center. We have a set of PowerEdge platforms that are purpose-built. They have the right amount of intelligent automation built in. They have cyber resiliency, taking advantage of the security features that Madhu talked about, all built on AMD EPYC. We complement that. I'd be remiss if I didn't say that we complement that with really awesome capabilities in object-based storage. As you get into these types of KV cache architectures, as you get into the data preparation, the storage architecture is more important than ever. We're talking about some really awesome things with our PowerScale products, our ObjectScale products, our AI data platform. This is going to be the engine that's going to feed all of these types of frameworks that we're talking about here today. Our networking, just as important with PowerSwitch and what we do there with the Fabric Manager and our capabilities there, and then our services all around that. We have the industry-leading rack scale delivery capability, and we're doing it all over the world, and our services are an important part to make that happen. And then I absolutely love the software stuff today with AMD. It was great context towards the end of the keynote. So excited about what they're bringing to the table and what we're able to build with AMD at the software layer. So with that, I think I'll turn it back over to Madhu. Appreciate you having me.
Thank you, David. Appreciate the deep partnership and the really deep portfolio that you have with AMD. So thank you so much. Now, I know customers like choice, and we partner across the ecosystem to make sure you have a robust ecosystem to deploy AMD platforms. And with that, I'd also like to invite Darren onto stage and talk about all of the work HPE has been doing with us and the deep partnerships there. Thank you, Darren.
Thank you. Thank you. I'm glad to be here. So you've heard about all of the innovation. So first, let me introduce myself. I'm a Senior Director of Product Management at Hewlett-Packard Enterprise. If it's ProLiant DL, ML servers, rack and tower servers, as well as our edge portfolio that falls within my team. So you've heard about all of the tremendous innovations that have been talked about around this next generation of EPYC processors. And when we talk to customers frequently about how can we turn that innovation into business outcomes, real business outcomes for the customers. And what we've heard loud and clear from them is that they're facing challenges. Challenges from the standpoint of three things. That AI is driving technology diversity. that customers are looking to deploy within their environment. They either have, they're running traditional enterprise applications alongside newer applications, analytics, emerging AI, workloads, as well as HPC. And so that adds a level of complexity that they need to be able to manage. And the greater that AI grows within their environment, the greater the complexity, and so obviously it is something that they have to be very focused on. Second is power and efficiency. They are becoming business priorities. As enterprises and organizations are looking to move their AI workloads from concept or from testing over into full production, they are also wanting to control their environment and control the cost that they're going to incur around the infrastructure cost, around the power and cooling cost, and just overall staying within the framework of the funding and the resources that they have. And then third is security continues to be foundational. That more than ever, customers need to stay focused on protecting their data, the data that they have in their environment. They need to protect their infrastructure, and they need to stay ahead of the emerging threats. And with that, they need that security to be built in and baked in, and they need that security to be easy to manage. So a lot of these emerging trends have started to show. We've seen them show up in the supercomputing area. And as an industry leader around supercomputing, HPE and AMD have partnered together for years in order to deliver the right performance and deliver the right innovation for the world's most demanding workloads. That's workloads such as scientific research or climate modeling or AI. And that is the reason why that we launched the HPE Cray supercomputing GX 5000. It's built off of the latest generation of EPYC processors, and it is focused on delivering a unified solution that comprises compute, storage, networking, and direct liquid cooling. Well, for some reason, I'm missing a slide. So the Cray supercomputing GX 5000, it delivers 40% more core density. It utilizes 25% less data center space with 25% warmer liquid within facility water within the environment to have a more optimized solution, delivering better performance and efficiency. And that same innovation that we talked about carries over and extends over to our enterprise portfolio. And as a strategic partner, HPE and AMD have worked very closely together and through the entire development of this EPYC portfolio that was announced today. And our engineering teams have designed and built platforms that will not only take advantage of the performance capabilities of the processors from not only the features but also the performance, but also will deliver on the HPE ProLine experience that our customers expect. Experience from AI-driven operations across hybrid environments, automated security with a silicon from a security that's been built from the silicon up, an infrastructure that is energy aware, and finally a future-proof I/O infrastructure, not only delivering on the features and the functions that customers are asking for and they demand in order for their infrastructure to be easier to manage and to reduce that complexity, but also delivering on the performance and the capabilities from the next generation of EPYC processors in order to address the workload requirements today as well as the growing requirements tomorrow. the partnership that we have with AMD has just been tremendous. And I'm so excited about being able to share the next generation and being able to share the future innovations that are coming from HPE that are right around the corner. Madhu, I'll turn it back to you.
Thank you very much, Darren,
Right,
and
thank you.
appreciate the partnership. Right. And just to close things out, right, Venice gives customers the right CPU choice across every major layer of the data center, 6 generations of leadership, and we have a portfolio that has come together nicely to serve the diverse workloads in an agentic era. We spoke about SP7, SP8, Venice X, and Verano, each purpose-built to address very distinct priorities and requirements and delivering performance leadership across those. And we have OEM choice to bring these to the market across a broad range of systems and rack designs, as both David and Darren pointed out. And that really brings out the true value of the EPYC 9006 series. So with that, thank you all very much. And we could take some questions if there's time. Yep, sure. Is there? Yes. So right now, an agent is basically a core, right? Because we are mapping an agent to a core, like a sandbox is a core. So it's number of sandboxes per rack. We were using a metric very similar to what competition was using. So think of it as either sandboxes per rack, which maps to cores per rack. That's the metric. Yeah. Correct. Yep. Any other questions? All right. If not, I think we can wrap up. Thank you all very much.